Hey 8th graders, we are on lesson 8, session 2, which starts on page 181, and we're still going over slope, just like yesterday in the explore activity, but for our develop session, we are illustrating how slope of a line is constant. The slope will not change. If the slope has changed, that means that the line has gone crooked on us. We're working with straight lines today, so the slope will be constant. Okay, so in our try it problem today, a delivery company uses robot dogs to deliver packages in an office building, and that is delightful, and I want to see that in real life. The graph shows how long a robot dog can operate for each hour its battery is charged. And our directions say pick any 2 points on the line. Find the slope of that line. Can you find any other pair of points where that will give you a different slope? So let's pick 2 points on this line. And don't just pick like literally random any spot. That's not going to work. You need to pick a spot where the points intersect at an x and y coordinate. So right here is a good one. And then right here is a good one. So we'll just do those 2 points first. And in order to find the slope, the term that you're going to memorize for the rest of your life, you can have it engraved on your tombstone someday, is rise over run. That is the traditional, as far as I know, traditional, easiest way to find the slope. I think I have that written in my middle school math notebook somewhere. So we're going to count the rise from this point from the first point to the second point. And notice these units are going by 10. So that does matter. Pay attention to the units on the side. So I'm at 30 and going up 10, 20, 30. So the rise here is 30. And then the run, notice these are going by halves. There's 1, 1.5, and 2. So I'm just going to go 1. Because it went 1.5, this 1, 1.5, 2. Okay, so the rise is 30, the run is 1, so slope is 30. Because you don't need that 1 under it, right? Okay, now it said to try another set, so let's do, let's see, we've got one right here. There's another place where it crosses. And then we can either do the lower one or the one in the middle. Let's do the middle one because it's closer. He'll give us smaller numbers. Give us smaller numbers. It's easier math. Okay, so rise is going to be 10, 20, 30. Well, look, that 30 over 1. Okay, still there. Okay, let's try one more because there's only 3 so that we can have all 3 combinations here. Why not? Let's go from the lower one. Let's pick orange. Ooh, yellow. I could do yellow because it's got a dark background. Yay. Yellow. From here to here. So we got 10, 20, 30, 40, 50, 60. And then 1, 2. So that one, I don't want to keep using the yellow, I guess. 60 over 2. Oh no, different numbers. Oh, but wait, I just divide them each by 2. And that is 30 over 1, just written in a different way, which again is 30. The slope is 30. No matter where you go or what you do, you can't escape it. Okay, now down on this next page here, page 182, we've got 2 modelets here. And these are not modelets that you necessarily have to use. Remember, we were exploring different methods. These are just here to illustrate for you why, different ways to see how slope is constant. But the way I need you to memorize, at least, is rise over run. That's the important one to me. But if these help you, then hooray. Okay, so the first modelet has right triangles translated. So choose any 2 points on the line, A and B. And draw in the segments that make them a right triangle, and then translate it up along the line, and you can compare them and that'll give you the slope. So we translated it what? We translated this point up by 3 and over by 1 whole, because remember these are halves. So that was how we translated. We translate up 30 and right 1. So slope is 30. So that's the translation will also give us the slope. You can also use dilations of right triangles. So we've got 2 points again here. We've got point A and point B, and they've scaled it down by a factor of 2/3. I can tell that because this is 1, 2, 3, and now it's at the 2, so it went down by 2/3. So they scaled it down, and you can see the difference between where B and D are. It's still going to be 1, 2, 3, and 1. 30 over 1, which is 30. Okay, so whichever of those helps you figure out helps you visualize slope, keep it in your mind. And if it doesn't help you, toss it out of your mind. But don't toss out rise over run. Keep that forever. Okay, but let's look at them before we toss them out. Don't toss them out yet. We still have to look at them. We have to do the look at model it. Okay. Are triangles ABE, triangle BCF, and triangle CDG congruent? How do you know? This is in the first model it. So look at the first model it. So are they congruent? Are they the same? Yes, they look congruent. So let's say yes. But how do we know? You can't just say they look congruent. I know you want to. Yes. Let's use our fancy math language. You can map them onto each other. By translating. And rigid translations are congruent. I won't make you write that. You can write that if you want to. Rigid translations are congruent. Okay, how can you use triangle ABE to determine the slope of the lines between points A and B? And what is the slope? If you translate it up 30 and right 1, that is the slope. There you go. And then remember, if I'm going too fast, just pause it, rewind it, whatever you gotta do. That's the joy of video. And then part C, 1C. Is the slope of the line between points A and B the same as the slope between B and C? Between C and D? Explain. Is the slope going to change? If you think it's going to change, if you're not sure, read the title of this lesson again. Slope is constant. So is the slope between them the same? There we go. Number 2. Now we're looking at the second modelet with the dilation. What is the slope of the line between points A and B? What is the slope of the line between points A and D? Didn't we already determine the slope? Have I said enough times yet? The slope is 30. Slope is constant. Slope is 30. Slope is constant. So you know what? I'm just gonna keep going. You're gonna have to see slope again. Let's look at from A to B. Let's go all the way from A to B. So we've got 10, 20, 30, 40, 50, 60, 70, 80, 90. Then we've got going by half, remember, because each of these is half, 1, 2, 3. So 90 over 3. That's from A to B. Okay, so we have between different points. We've got 90 over 3, which is the same thing as 60 over 2, which is the same thing as 30 over 1, which is the same thing as just 30. It's not changing no matter where we go or what we do. It will find us. So let's say it one more time. Let's do it in cursive this time. Slope is constant. That's a terrible N. I'm not fixing it. You're just going to have to live with it. So we'll put a heart over the I. That'll help. Fix that T. There we go. Slope is constant. Number 3. Both models started by choosing points A and B. How do you know the slope of a line is the same between any two points on a line? Well, why did they pick A and B? They made them A and B, right? Because you can pick any. Points A and B can be any points on the line, because, say it with me now, slope is constant. There we go. Okay, and then number 4 is for you to do. Which part of this lesson helped you better understand that slope is constant? Was it seeing it illustrated and modeled, I should say, as translations of right triangles? Was it seeing it modeled as dilations of right triangles? Was it writing slope is constant like 30,000 times? That's an over-exaggeration, whatever. So pause, write down the part of the lesson that helped you most understand slope is constant, and then unpause and we'll practice. Okay. There we go. Let's do, how many practice problems? 3? It's always 3. Why do I even look? It's always 3. Alright, 3 practice problems, and I'm excited about this one because I love honey. I eat honey almost every day. So Jamila is selling honey for number 5 here. She posts this super cute sign for her customers. Then she makes herself a graph because she likes graphs just like I do. She likes honey and graphs. We have so much in common. Then she makes a graph that shows the price of each jar. Is Jamila's price the same per ounce for any size honey? Well, it's a straight line, right? There's no discounts. If there was a discount, there'd be a little crooked spot where you get a little bit more ounces per less money. So let's see, how do we put that down in English now? Is the price per ounce the same for any jar? Yes. Now, the important part, explain. Can't skip that. The line is straight. So the price per ounce is constant. And if you want to be a super diligent student, you can double check this by looking at the price per ounce for each of the prices on her list. So you would say 5 ounces, oops, I don't need 50, 5 ounces for $4, that's $1.25 an ounce. Then you could say 10 ounces for, yes, 10 ounces for $12.50. That is $1.25 an ounce. Then you could look at 15 ounces for $18.75. And you can use a calculator for this. I won't yell at you because you'll also see that's $1.25 an ounce. It's constant because slope is constant. Okay, number 6. Akio draws a graph to record the distance he rides on a long bike ride. What is the slope of the line for the first 2 hours? What is the slope of the line for all 5 hours? What does the slope mean in this situation? Okay, so let's see the first 2 hours. Here's the first 2 hours right here. So here it is at 2 hours, and we can pick any points under that, right? So let's do 0, 0. No. It's easier math when you keep the dots as close together on the line as you can. So let's just keep it easy. So we're going to go rise, and these are each, what, 10? The unit rate's 10, 0 to 20 with this in the middle. So, okay, so the unit distance is 10 on this, on the y-axis. So we're going up by 10. And then it looks like the unit spacing on here is 1. So this is 1. So 10 over 1 for the first, what is it, 2 hours? Okay, now for all 5 hours. So the slope is 10. What's it going to be for all 5 hours? Do we even have to do the math? Because slope is constant. Do we need to do the math? No. Slope is 10 all the way across. And what does the slope mean in this situation? Well, this is miles and this is hours. So the slope means 10 miles per hour. There we go. Number 7, Lupita drew a graph to describe her airplane trip. How nice of her. Is the slope constant for the entire trip? Explain. Look at this closely. Look at it straight on. Don't look at it at an angle. Put your face right in front of it and give it a good look. Is that slope constant? Uh-oh. I'm going to use my line tool just to make double sure, because I can. Since I'm on my computer, might as well. Very carefully start my line down here. Ooh, look, it gives me an angle. That's cool. And dun dun dun. It's not constant. There's a bend in it. So let's see. Is the slope constant? No. There's a bend in it. And let's see, what does that bend mean? She was going at this rate for the first 2.5 hours, and then it looks like they slowed down a little bit. Must have hit some turbulence. Okay, that's it for our practice questions. Now you do your own green pages, and I will see you later.